Assalamu alaikum, bismillahirrahmanirrahim. Just we have discussed Juniper certification. Juniper certification was JNCIS-SP. Last day we have discussed IP tunneling. When you create IP tunneling in your Juniper device, I showed you how to configure those tunneling requirement, how to um, establish connection from one source to another destination over the internet. So today we discuss another module. Today's module is GR and BFD. GR means graceful restart and BFD means bidirectional forwarding detection. Both are used in Juniper device for high availability. Okay, so let's start. So just think this slide just show you what is high availability. Just mean first is availability, like you are available when you knock WhatsApp another person he is available or not. Okay, so in network device, consider uh, we access internet 24/7. Okay, so in that case network device should be off 24/7, but in some cases maybe have software problem in your devices, maybe power outage. In that case maybe link outage. In that case your availability will be reduced. Okay, that means you will not get the internet access through that device. That is called the unavailability or unavailable. In otherwise, you can say it's a downtime when you can't access internet over the over those devices. You can say it's a downtime. So high availability means just consider based on customer consideration and make maximum availability, just make ensure maximum availability. You have to consider redundant device, you have to consider redundant link. Okay, in that case you have to consider redundant protocol also. So we are discussing today what will be the redundancy protocol, okay, to make uh, high availability of your internet connectivity. Okay, this is the main focus point of today's topics. What is high availability? Another picture you see. Just we are just accessing. Just you consider, we are accessing different resources from through the internet. So now we are accessing you. Now I accessing you through the Zoom apps. Okay. So if internet connectivity now goes down, our availability will be disconnected or our connectivity will be disconnected. Okay, so we are going to unavailable. So this is just a summary. Availability, normally we show availability as a percentage. When you purchase any. No, it's a, JNCIS-SP course, not JNCIA. JNCIA's schedule time was 6 to 7 p.m. every Sunday and Tuesday, but I have missed. Okay. Now you are enjoying JNCIS-SP. Okay. So normally we mention availability as a percentage, like say here availability. They are showing one column availability. Availability is 90%. Means our total days in a year is 365 days. Okay, 365 days. If you say 90% availability, that means per year downtime will be 36.5 days. And if you convert it in hour, that will be 72 hours. That means 30 days per month, 72 hours. If you convert it in hours, downtime per week will be 16.8 hours. That is first statistics. If you see the first row, this is not acceptable for nowadays. This is not acceptable. Okay, so if you just think last one, 99.999%, that means see here downtime per year 31.5 seconds. This is high available. You are ensure high availability. Okay, so normally availability we express as a percentage. If you consider just a redundancy, you can say a redundant device, you can say redundant link or redundant connection. So if you consider this, you have to consider also the protocol. If your redundant device link and protocol will be used in your network, your availability will be increased. That is the main thing. High availability networks. These are some key consideration. It's just a theoretical concept. So see here, high availability features. Juniper or Junos OS supports multiple high availability features. These features like this: graceful restart. I will discuss every topics in next slide one by one. So just see here how many high availability feature in Junos. Number one is graceful restart. Second one is graceful routing engine switchover. You can say Grace. Non-stop routing, you can say NSR. Bidirectional forwarding detection, you can say BFD. Virtual router redundancy protocol, VRRP, and unified in-service software upgrade. These are the high availability feature which you can configure in your Junos devices. So first, we try to know what is this. First, we try to know what is this. Number one, graceful restart. What is the graceful restart? Say here, 2 points is here. Number one is enables uninterrupted packet forwarding and temporary suppression of all routing protocol updates. That means if you enable graceful restart, as per protocol, you can enable in OSPF, you can enable graceful restart in BGP. So this will gives you enable uninterrupted packet forwarding and temporary suppression of all routing protocol updates. That means you will your packet will not be dropped if you enable graceful restart in case of redundancy. Okay, enables a router to pass through intermediate convergence steps that are hidden from the rest of the network. That means just consider multiple router is interconnected in a domain. You are just running OSPF routing protocol on that devices. If some devices goes to restart event, So neighbor device, they just tell the neighbor devices, I will be restart. So those devices don't send any packet to restarting devices. This is the main mechanism of graceful restart. That means you can say before die you have you I can say before die you want to communicate. Before die you can communicate with neighbor. That is the feature of this feature is called the graceful restart. Another one is graceful routing engine switchover. Graceful routing engine switchover. If your router have multiple routing engine, some Junos device have multiple routing engine. You can say MX multiple model have multiple routing engine like MX480, like MX2K. Those are multiple routing engine. So if you have or if your router have multiple routing engine, you can enable graceful routing engine switchover. Grace for what or for why? Reason, if your one routing engine failed, your traffic automatically switches over to another routing engine and your forwarding will not be interrupted. That is the reason. Okay. So see here, enable uninterrupted packet forwarding and temporary suppression of all routing protocol updates. Enables the router to pass through intermediate convergence state that are hidden from the rest of the network. This is the another good feature when your device have multiple routing engine. If your device are running in single routing engine, no need to enable this one. Okay. Number three, non-stop active routing. Non-stop active routing, you can say NSR. If same thing, if your router have multiple routing engine, you can enable non-stop active routing NSR in the same case. Non-stop active routing uses the same infrastructure as egress to preserve interface and kernel information, is self-contained or does not rely on helper router to assist the routing platform and restoring routing protocol information, is a natural replacement of graceful restart. Okay, so this is the another high availability feature, which is very fantastic. Next, virtual router redundancy protocol. You can already know this protocol. This protocol basically makes sure on the redundancy you have considered multiple router. You can say two router. You can say more than two. You just make high availability. You are just making high availability. For that reason you are purchased multiple router, and multiple router you configure redundancy protocol like VRRP. If your one router is goes down, your customer will not goes down. So this is the high availability feature, which ensure high availability. Okay, so enable host on a LAN to make use of redundant routing platforms on that LAN without requiring more than the static configuration of single default route on the host. At any time, one of the VRRP routing platform is the master and the other are backups. When two routers participate in VRRP, one router will be the master, another router will be the backup router. For single subnet, if you use multiple subnet, you can consider backup router will be master router for second subnet and master router will be the backup. Okay, you can alternate. for load sharing. Okay. If the master fails, one of the backup routers becomes the new master router, providing virtual default routing platform. So if your master router goes down, traffic will automatically switch over to backup router. So this is another I believe to be sir. Last one, ISSU, Unified In-Service Software Upgrade. Okay, just you consider you purchase two devices. Now it can be any model, okay, that have multiple routing engine. After some year, your software already upgrade. You want to upgrade your software in your devices. So you have multiple routing engine. So you have to upgrade both routing engine software. Okay. So in that case, if you upgrade it manually, you have to consider downtime. You have to consider downtime. Okay. So how to avoid this downtime? Just configure unified in-service software upgrade. Enables uninterrupted packet forwarding and temporary suppression of all routing protocol updates. Is supported only on dual routing engine platforms. Dual routing engine. If you have only single routing engine, no need to deploy this high availability vessel. So most of the case have dual routing engine. So again, just graceful restart. See, given the sample topology, what would happen if R1 routing protocol process RPT restarted? See the topology. OSPF is running in router 1 to router 6. So what if just consider R1 just restarting their routing daemon, what will happen? So if any packet is traveling through the R1, that packet will be dropped. If I enable graceful restart, then this router tell the neighbor router, I will be participate in graceful restart event. So don't send any packet to me. Okay, don't send any packet to me. So those router considering these are a restarting router, then our routing table will be resynchronized, and after resynchronize, all packet goes to another path which is travel through R1. This is called the graceful restart. See here, OSPF addresses with R1 must go down. Path is transmitting R1 must be recalculated based on the new topology. Consider down, and those are up. This router recalculate or resynchronize the route table. After resynchronize the route table, packet forwarding path will be changed based on topology, where R1 not participating. Okay, so R1 is known as the restarting router in graceful restart terminology. Same thing. Once R1 recovers from the restart event, R1 synchronizes with its neighbors without disrupting packet forwarding automatically. Okay, after completing restart event, they are participating normally and synchronize the route table or forwarding table, and traffic will go as like before. Okay, this whatever is the basically multiple pizza. I'll just try another one. Graceful restart support and requirements. So router must have graceful restart enable. You have to enable restart. Restart, graceful restart. You have to enable. Okay. Otherwise, it will not work. You can enable restart, graceful restart under a different protocol. You can enable restart, graceful restart in under WSP. You can enable graceful restart under PGP. Okay. Or you can globally enable graceful restart for every protocol. Okay. So restarting router mode, helper router mode. This is the two mode basically. This is the picture. Basically, routing engine and forwarding engine, they are interconnecting when packets incoming in incoming port, and just checking the forwarding table and passing the those packet to the outgoing port. This is the basically control plane and forwarding plane. How to configure graceful restart? Okay, graceful restart helper mode is enabled by default. By default, graceful restart enabled in JNCIS-SP. No need to enable manually. Okay, disable graceful restart helper mode. If you want to disable graceful restart for every protocol, just to go to routing options and graceful restart disable. Or you can disable and see here. This is the configuration of BGP. Just BGP specific group, and you can disable graceful restart. So graceful restart you can enable or disable per protocol. If you consider BGP, you can disable or enable in global BGP portion. You can disable enable in a group. You can disable enable per neighbor. Okay. And this is the YSPF, set YSPF graceful restart. You can disable, but by default, graceful restart enable in JNCIS. No need to enable manually. Okay. So another high availability feature is bidirectional forwarding detection. And this is very helpful for a large environment, basically, when link interruption happened frequently. So if you configure bidirectional forwarding detection, it will help you more. Okay, just consider, just consider you are connected tier 1 transit provider, like you are connected like Bharti, you are connected like Tata, you are connected like Hurricane, you are connected like Cogent. Okay, this your router. Okay, so these are connected, and you configure here ABGP. So just consider this just for example. Is the Bharti circuit. You have just multiple link flapping. You are getting now multiple link flapping. If you get multiple link flapping just for short time, so you just consider around 9 lakh routes for IPv4. BGP carry around 9 lakhs route. This route are installed in this route table. If BGP goes down, it take time. How many? How many second? Juniper will take default 90 second. Other device will take 180 second, like Cisco MikroTik. So this 90 second is big time. BGP will hour after 90 second. After 90 second, BGP goes down. But your route, which is receiving from Bharti, this route is installed in your route table. So your back-end user customer traffic automatically send the packet to Bharti, which is received from this router or active route in this router. So in that case, this packet will not basically communicate because your link is down, but BGP takes time, 90 seconds. Your packet will be dropped. So if you think, so I can add one helper for BGP. I can add one helper for BGP. That would be bidirectional forwarding detection. This BFD protocol detect link failure in a second. Okay. So just if I enable BFD under the BGP protocol for this neighbor, they detect the link failure. Yes, link failure happened here. So no need, no need to send your prefix to this router, or this router also not sending any prefix to this router. So in that case, your traffic will be divert to another upstream and your user packet will not be dropped. After interruption, your circuit name is stable, BCP established, you receiving the route, your receiving route installed in route table based on BGP attribute, then your packet will be traveled. So in that case, you can add BFD. BFD can be used under BGP. You can use under OSPF. Okay, no issue. Detecting network failures. I already discussed. All modern protocols such as OSPF and BGP include some mechanism to detect network failures. The problem, failure detection mechanism can be slow. That is the reason. It's slow. OSPF take 40 seconds. BGP take default 90 seconds for Junos, but another vendor it take 180 seconds. That is big time. Okay. So I have to detect network failure in a short time. What will be what we have to deploy to detect network failure in a short time. Okay. Bidirectional forwarding detection, BFD is simple protocol designed to rapidly detect link failures, typically under 1 second. See, 1 second. Network failed. You would just know within 1 second. They are just communicating BFD hello, like we speak. Okay.
I have one query. That means in BFD, if we have
Mhm.
multiple upstream, if one
Mhm.
upstream, one of our major upstream down, that means within 1 second, the whole traffic will be shifted into another upstream. Am I right?
1 second, they are detecting time, but they are announcing maybe it use multiplier basically. It can be uh, it can be 1 second or more than one, maximum 3 second.
Whole traffic will be shifted within 3 seconds.
Right.
Uh, Actually, what I have another query. What is the actual? What is the advantage of graceful restart? Could you please repeat it again?
Graceful restart. It's just consider
Hmm.
one task assigned for 5 people. One people just feeling sick. One people just feeling sick. Sick people announce others people, I'm sick. So need to rest. So need to take rest. Okay, take rest. I'm doing rest of the work. Okay. So 4 people doing the task. If the same people feeling okay, they're just join and work together. Clear?
That if I use graceful restart in a BGP neighbor, that means if I disable that neighbor, then
Mhm.
how? Actually, I don't
When,
clear.
when restart event occurred on that device announce the neighbor device, I'm going die.
Okay.
Don't send any packet to me. So
Then
your
how that packet will be served?
just resynchronize your topology and just packet travel the alternative path.
Okay, okay, okay. Money, that means there are multiple paths.
Obviously, multiple.
Okay, okay, okay. Got it.
We are just talking high availability. Multiple path must.
Okay, okay, got it.
Okay. Bidirectional forwarding detection. You can enable bidirectional forwarding detection under OSPA, PySize, 3, BGP, RSPP, PIM. Also static routes. You can enable. Okay. So see the key benefits of BFD. Number one is relief supported protocol by providing fast failure detection. Protocol timers can be left at their default values or even be increased or reduced processing overhead. Okay. Provides single common method of managing protocol timers rather than the modifying the relevant timers for each protocol running in the network. So no need to modify OSPF hello time, OSPF hold time, BGP whole time. No need. Just enable BFD. BFD will work. No need to customize any other protocol hello or hold time. Okay. Configure BFD. Just how to configure BFD. If you consider WSPF, just go to the WSPF routing protocol and under interface, enable this one. BFD liveness detection, minimum interval 300. Here 300 is millisecond, not second. 300 is millisecond. Okay. So 1 second means 1000 millisecond, right? They are sending 3 times. If got 3 times failed, they declare something wrong and award the OSPF your link has failed. Take decision. Okay. Same like this, you can enable BFD under group. Just set here minimum interval 300 second. The transmit and receive interface should never be set to value lower than 300 millisecond. Lower than 300 millisecond, it is quite complex for device communication. So no, don't reduce the minimum interval time. Just 300 millisecond is perfect, or you can consider more than 300 millisecond. You can set 500 millisecond if your consider link is remote, like Dhaka to Singapore, Dhaka to you can say Dhaka to Chennai or Dhaka to Delhi. In that case, you can set minimum interval more than 300 millisecond. Okay, but 300 millisecond is recommended. You can use this. Okay, configure for two and just BFD liveness detection. Same thing, same configuration. Just go to the protocol set BGP. This is under protocol. See here, not specific protocol. Every protocol is under this. BGP, OSP, RSVP, LDP, everything. Huh? For everything, for every protocol, you can set BFD liveness detection. You can set. No need to define under OSPF, BGP, just set for every protocol. Or you can set for BGP, just under BGP protocol. That means edit protocol BGP and set the BFD. Set BGP. Here, see here, this BFD is setting globally for BGP protocol. So no need to redeclare for a specific group for a specific neighbor. All neighbor BFD enabled. If you consider like this, see here, set protocol, set OSPF area, then interface. This is the previous ones. See here, you can set BFD under protocol. I show you under group, under neighbor. Okay. Monitoring BFD. This is just the verification command. After configuring BFD, show BFD session. After configuring BFD, you are just checking. Show BFD session. If session is off, you say the start. Yeah. And here, see the multiplier. Default multiplier is 3. So you are sending BFD hello, interval is 300 millisecond, and here multiplier is 3. That means BFD, if BFD hello fails 3 times, then our the protocol link has failed. Okay, so that's all basically for high availability. Now we go to lab and check BFD bidirectional forwarding detection, and another one is graceful restart. For graceful restart, there is multiple event here, but in our topology, this a virtual one, and this not have multiple routing engine. In that case, I cannot configure graceful routing engine, switch over non-stop routing, and Juniper service software upgrade. Okay. And BRRP configuration is not here. I think BRRP configuration in separate slide. So now we configure two things: graceful restart and BFD, bidirectional forwarding detection, and check and verify it's working or not. Graceful restart. So by default, graceful restart already enabled. Graceful restart already enabled. So if you want to enable graceful restart, just go to edit routing options and set GRA graceful restart. See here, no enable option is here. Graceful restart already enabled. So if you want to disable this one, so you can set here disable. This is the global options. This is happened for every protocol. If you want to enable or disable under protocol BGP, set graceful restart. See here, you can disable graceful restart for BGP. This is happened for every neighbor in this router. Okay, if you want to edit group name is BMX1, there have no group. Okay, test set graceful restart. You can also apply graceful restart under group, also under neighbor. Mm, this delete group test. Nothing. Right. So another one is BFD. So how to configure BFD? It's very simple. When you configure BFD, you can configure BFD under group or WSPF under interface. You can set BFD information. Okay, so or BMX2 and BMX3 maybe those have WSPF routing, WSPF neighbor. Yes, WSPF routing is running here. Okay, so under WSPF protocol, edit protocol WSPF, this is area 0, set area 0, and the interface is 0 by 0 by 1, 1, and you can see the BFD information. Bidirectional forwarding detection, BFD liveness detection. And you set the minimum interval, minimum transmit and receive interval in millisecond. So minimum interval, you can set, I set here 300. Say this one, done. It. Run show BFD session. Enter. Session is down. Interface is this multiplier. Default multiplier is 3. So set similarly in router 3. Edit protocol, or you can set like this. Set protocol WSPF area 0 interface with interface GE, then BFD liveness detection, and set the value 300 millisecond. What is this? Oh, minimum interval. Then set the value 300. Commit. Check now again. Down. Yes, up. And detect time, transmit interval. This is the detect time and this is the transmit interval. If you see detail, see extensive. See here, 10002 your peer and your BFD session is up now. Detect time and multiplier is 3 used here. And client WSPF version 2 area 0 transmit interval 300 millisecond and receive interval 300 millisecond. Remote is set up and BFD version 1 is used here. And this is a single hop BFD, that is a directly connected BFD. Minimum asynchronous interval. Slow interval is 1 second. Multiplier 3 is used. That means multiplier 3 means just 3 times. They send 3 times. BFD hello 3 times. Then take decision and share this decision to OSPF. Something happened. Okay.
Is it possible to use BFD for whole OSPF protocol instead of using a specific interface?
Specific interface. Very good question. edit protocol OSPF. Just say here set BFD. No option here BFD. Have any option BFD? Backup? No. No way, no way, no way. Okay. So set area, the mention. See here, any BFD option? No. So for voice PF, there is no option. Okay. You
Okay,
have to enable under
but
interface.
for BGP you can do it, right?
For BGP, just check edit protocol BGP group IBGP. And I'm under BGP group. So under BGP group, BFD should be available. BFD available under group. Okay. If I set BFD under BGP, not a specific group, right?
Yes.
Set. Set BFD, yes, possible. Possible. Every neighbor, every group, BFD library detection will be enabled. If you set like this. Clear?
Yes, clear.
Okay. So that's all for today. Next,
Sir, one small
I
question from my side.
yeah,
I'm audible,
yeah.
right? Sir, actually, right now I'm learning the Juniper also. So I need some images, okay, whatever you are using in these router images. So can you
Mhm.
share with us, sir, in the WhatsApp group?
Of course, of course. After class, I will share in WhatsApp group. Okay.
Actually, I visited the Juniper portal. There I saw
Mhm.
some mm, uh, we forwarding and we CPU something, right? We routing
Yeah, yeah,
issue.
yeah. Right, right.
But
If you
here I'm
see
not
in
seeing
the
here is a
the official
single.
website, you can you also see VCP and VFP.
Actually, my laptop doesn't have a good configuration, so can you
Mhm.
share with this only this single?
Obviously, obviously. After class, I will share with you. Okay, for sure.
Okay, thank you. Thank you so much, sir. Thank you.
Okay. Thank you, Prakash. So, any other query for today's lesson?
No,
No,
sir.
right?
Yeah.
Okay. Thank you. Thank you very much. Allah Hafiz.